All right, for this video lesson, we will be talking about the hand trick, and this is used to evaluate the exact value of trigonometric functions. In order to begin this, we're going to have to reintroduce and revisit things like the bell work here on the board. We're going to evaluate the 6 trigonometric functions for the triangle using angle B. And then number 2 there, we're going to draw things in standard position, as well as find the reference angles that are given by each of those. Okay, so for number 1, we're going to start that by finding the value of C, because we're missing the value of C. So again, we do that by a squared plus b squared equals c squared, otherwise known as the Pythagorean theorem. You're going to plug in the values that you know. So we have a is 4 squared plus b is 12 squared equals c squared. 4 squared is 16 plus the 144 is equal to c squared. That gives me 160 equals c squared. If we take the square root of both sides now, we check to see if square root of 160 is a perfect square, or if there are any perfect square factors in 160. 160 itself is not a perfect square. 12 squared is 144. 13 squared is 169. So 160 is in the middle of that. Okay, so 160 is not a perfect square. However, it does have perfect square factors. Again, my suggestion is creating the U, list down all the factors, so you have 1 times 160, 2 times 80, 4 times 40, and continue. But what I'm going to do, just for the purpose of saving time here, is we're just going to go ahead and go to it. This is the square root of 16 times 10 is C. Square root of 16 is 4, so it's 4 square root of 10 is the value of C. Okay. In finding that, I'm going to go ahead and label my triangle here. Again, you can label it as you want, as long as angle C is here in the bottom right angle corner. Okay. I'm going to put A again, just staying up consistent. Again, the measurements don't necessarily match up, but staying consistent with what I do here. I'm going to put angle A up top, angle B down here in the bottom right hand corner. And then the opposite of these angles, remember, is the lowercase sides. So the opposite of angle A is side A down here. That is 4. Opposite of B here is B, which is 12. And then C here is the 4 square root of 10 that we just found. Okay. To evaluate the 6 trig functions, again, we're using the angle B here, so make sure you pay attention to that. Again, that's essential because we're going to go to angle B here, and what I do is I just draw the arrow and indicate which one is my opposite side. The right angle opposite side is my hypotenuse, and that makes this then my adjacent, ADJ. Okay. On all of these, when we're evaluating the trig functions, my suggestion was always to write out the expression or the mnemonic device of so, ka, to. Okay, because that's going to help me write out my ratios over here. Okay, so starting with sine, sine is the opposite, so sin of angle B is equal to the opposite divided by the hypotenuse. Okay. And again, looking at my picture here, my diagram, I can see that the opposite is 12 and the hypotenuse is 4 square root of 10. So I have 12 divided by 4 square root of 10. Okay. We can simplify here. 12 divided by 4 can reduce to become 3 over 1. So I have 3 over the square root of 10. Okay, but remember here, you cannot have a square root remaining in the denominator. So I'm going to have to rationalize the denominator. So I need to multiply the top and the bottom, okay, the numerator and the denominator. by the square root of 10. Remember, it's exactly what the square root is down here. This is going to give me 3 square root of 10 divided by 10. Okay, remember, the square root of 10 times the square root of 10 is the square root of 10 squared, which means the square root and the square will cancel, similar to what they did here with the c squared and the square root. Okay. Cosine of b now is the adjacent, okay, CAH, adjacent, divided by the hypotenuse. That is 4 divided by 4 square root of 10. And continuing. Reduce here, we got 4 divided by 4 is 1, so I have 1 divided by the square root of 10. And again, I had to rationalize the denominator. I had that square root in the bottom, so I need to get rid of that square root. So I multiply by the square root of 10 in the numerator and denominator, which here gives me the square root of 10 over 10. Moving on to tangent. Tangent of angle B is equal to the opposite divided by the adjacent, TOA, tangent, opposite, adjacent, is equal to the opposite, which is 12, over 4, the adjacent. Reduce this, it becomes 3 over 1, or just 3. Okay, those are the 3 original functions. We're then going to find the 3 reciprocal functions. So the reciprocal function of sine is cosecant. So C, SC of angle B equals. And remember, again, we're going to take whatever one we can backtracking through the work, and we're going to flip it. So 3 square root of 10 over 10. If I took this and I flipped it, I'm going to put that square root in the denominator. I don't want to do that. Okay. Here, the square root of 10 over the square root of 10, that was just used for simplifying purposes. But if I take this 3 divided by the square root of 10 and I flip it, that gives me an answer that I don't have to reduce. So the square root of 10 over 3, that is my answer. Moving on to cosine, the reciprocal function of cosine was the secant, S-E-C, so S-E-C of B. And again, we're going to backtrack through the work here, square root of 10 over 10. If I flip that, I'm putting a square root in the denominator. Again, we don't want to do that. Square root of 10 divided by square root of 10, that was just to simplify. But if I take this one here and I flip it, I have the square root of 10 over 1, or just the square root of 10. And finally, the reciprocal function of tangent was cotangent, so COT of angle B is equal to the reciprocal of 3. Or if I can backtrack one more and I flip that, that becomes 1/3. Okay, number 2. Remember again, when graphing angles in standard position, you have to try to get the angle that I give you between the values of 0 and 359 degrees. I don't care if it's positive or negative, it has to be one or the other. Okay, if it's given in negative, get it between 0 and 359 negative. And if it's positive, get it between 0 and 359 positive. Okay, so for the first one here, we're going to subtract a full rotation, or 360 degrees. That gives me 15 degrees. Okay. I'm going to draw my initial side. Remember again, the initial side is always here on the positive x-axis. And then we're going to go up to my additional, or my extra 15 degrees, which is just a little bit. Just a little bit above the x-axis. Okay, so we'll call it here. And remember, again, we have one rotation here, so this is one rotation. And then we have the extra. So I start here because it's positive. I go up first, that's 90 degrees there. I go up and around, that's 1, and then finish it out. Okay, the added step of the reference angle is then again looking for the closest x-axis to that terminal side. So if I'm looking at the terminal side here at 15 degrees, then it's closer from here to here than it is from here back. Okay, so I'm going to use this angle here because again, it's the closest. And I'm going to try now how many degrees is between here and here? Well, it's 15 degrees. Okay, it's 15 minus that 0, which is 15 degrees for the reference angle. Okay, for the next one, negative 755 degrees, we're going to add, because this is a negative number, instead of subtract, we're going to add 360. So if I add 360, I get negative 395 degrees. I would then add another 360 because I'm not between 0 and 359. So I'm going to add 360 again. And that gives me negative 35 degrees. Okay, again, now that we're between 0 and 359 degrees, I can go ahead and plot. So that means I have my positive initial side. Okay, and I'm going to go down 35 degrees because this is negative. So now my rotation is clockwise. Okay, 35 degrees is a little less than halfway, but it's fairly close. We'll call it there. Okay, hopefully your line's a little straighter than mine. I have 1, 2 full rotations and then the extra. So here now, again, I'm going down first because it's negative. I'm going to start here, go down and around, 1, 2, and then the extra. Okay. And the final aspect here is, again, finding the reference angle. It's finding out how many degrees is between the terminal side that we just draw and the positive x-axis because it's the closest x-axis. Okay, so from here to here is a lot closer than from here to there. So we're going to find this measurement. So if I go from 0 degrees to negative 35 degrees, okay, I can see that that is 35 degrees for my reference angle. Okay, moving on to the lesson. Again, we're talking about the hand trick with this section. First thing is a lot of review. Okay, we've done a lot of things building up to this point, so we have to go over them and just make sure that we understand them because, again, they are essential to this section. Reference angles, again, that we just did. The definition is the smallest angle that the terminal side of the given angle makes with the x-axis. Okay, again, it has to be the smallest one. Okay, key things to remember here: they are always, always, always positive, and they are always less than or equal to 90 degrees. So they can range from 0 degrees up to 90 degrees. They are always positive, though. Finding the reference angles, again, we just did this on the bell work, so it shouldn't be that complicated, right? You're going to draw the angle in standard position. Again, my suggestion is to continue to do that as practice so that you comprehend how to do it and remember which way to go and rotate to create that angle. Okay, step 2, then you're going to drop a line, and the bell work, what I did was draw that little orange line showing me which one was a closer angle to the x-axis. Okay. You don't have to necessarily do that. Again, that's up to you. This is just a suggestion. Okay, and then step 3, they're going to find the measurement of the angle between the x-axis and the terminal side. Okay, you're going to use a lot of 0 degrees, 360 degrees, and 180. You will never use the angles of 90 degrees and 270 degrees, because those are the ones that are falling on the y-axis. We are focused solely on the x-axis. Okay, evaluating trigonometric functions using the hand trick. Okay, I'm going to give you a hand here, pun intended. Okay, if you look at the palm, there's always a over 2 in your palm, and then each finger represents a degree measurement for a reference angle. Okay, going up, we start with the pinky, that is 0 degrees. The ring finger is 30 degrees. Your middle finger is 45 degrees. Your index finger is 60 degrees. And your thumb is 90 degrees. If you're a right-handed person, you will typically use your left hand to look at. Okay? And if you use the left hand, like what's represented here, then you can consider this to be your first quadrant. Okay? If you extend out your hand and spread out your fingers, you can kind of see the first quadrant. Okay, the thumb and the pinky make that right angle. If you draw a line down to connect them and then over. Okay, the middle finger would then split it in half, and then your ring finger and your pointer finger would split it into thirds. Okay, so that's a way to remember it. No, you cannot come to class with this written on your hand. No, you should not go get a tattoo of this. Even though several people have said it and mentioned it, I have yet to see somebody actually do it. Will you use this again in your life? Probably not. So try to explain why you have 0, 30, 45, 60, and 90 on your fingers later when you're about 55, 60 years old. Okay, it'd be a little crazy. Okay, this page will take a little bit to get through and explain. Again, this is just the procedure on how to do the exact value of the given function. Okay, I'm going to break this apart on the worksheets into 3 sections. First part there is just finding the reference angle. Okay, the reference angle here, unlike what we've done before, has to specifically be one of the 5 that I'm indicating here. It has to be 0 degrees, 30 degrees, 45 degrees, 60 degrees, or 90 degrees. If it is something else, you've messed up. Okay, you should check it over. All right, step 2, then you're going to identify the quadrant that the terminal side is located in. This will tell you the sign of your answer. Okay, will it be positive or will it be negative? So if you look at the quadrant or the coordinate plane that I give here, you need to know what quadrants are. So if we look at this, this is a coordinate plane. It starts with a C. So most people draw a C and they start up top and they go around. Okay, that tells you which quadrant is which quadrant because we hit this one first. We hit the second one here second. This is quadrant 3 because we hit it in the 3rd section. And then this is quadrant 4, IV. Okay? There are 6 different possible answers here, even though there are only 4 quadrants. So what are the other 2 additional answers here? You could have the x-axis, because if the terminal side falls on the x-axis, that's not in a quadrant. Okay? That's on the x-axis. Your other possible answer would be the y-axis, okay, because it falls on the y-axis and not in a quadrant. Okay, a way to remember which values are positive, which values are not positive, is there in the red. The note says all students take calculus. Okay, if you look at quadrant 1, word 1 states all. all values, no matter if you're taking the sine, cosine, or tangent, would come out to be a positive result. The second word, students, S stands for sine in quadrant 2. The only value that you take that will come out to be positive is sine. If you are taking cosine or tangent, your answer should be negative. Third word and third quadrant, T or take stands for tan or tangent. If you are taking the tangent of a function or a value, then the answer will be positive. If you are taking sine or cosine, the answer will be negative. Okay? On quadrant 4 or word 4, calculus stands for cosine. If you are taking the cosine of some number, then the answer will be positive. However, if you are taking the sine or tangent of a number, then that will be negative. Okay, step 3 here. You're going to, again, hold out your left hand. And I always say this left hand because, again, I'm right-handed. If you are a left-handed person, you'll hold out your right hand. It doesn't matter. And you're going to recall the angles that were given on the other slide. Okay, so again, your pinky finger is 0 degrees. Your ring finger is 30 degrees. Your middle finger is 45 degrees. Your pointer finger or your index finger is 60 degrees. And your thumb is 90 degrees. Okay. Number 4 says to lay down the finger that represents the reference angle that you were given. Okay, so if you have a reference angle of 45 degrees, you will lay down your middle finger. Okay, so again, I have my hand, 45 degrees is the middle finger, I would put down my middle finger. Okay, if my reference angle is, let's say, 90 degrees, I would take my hand and I would sit down my thumb. Okay. If it's 0 degrees, I would hold out my hand and I would lay down my 0 degree finger. Okay? That leads to this part. If you are evaluating the sine of the value, then you are going to count the number of fingers below and take the square root of that and divide it by 2. Okay? So that means if I have, let's say, 60 degrees for my reference angle, I'm going to put down my 60 degree finger. And I'm going to count the number of fingers below. Okay, that's 1, 2, 3. So it'd be the square root of 3 divided by 2. Okay, I cannot simplify the square root of 3, so that would be my answer. Okay, cosine of A is similar, but now I'm going to take the square root of the fingers above. So again, using that 60 degree reference that I just had, I'm going to put down my 60 degree finger. I'm going to count the fingers above my finger that's down, and I only have 1. Okay. The square root of 1 can be simplified. So you would take the square root of 1 and get 1, and you would divide that by 2. So your answer there would be 1/2. Tangent of A is now the square root of the fingers below divided by the square root of the fingers above. So if I again use that 60 degree reference here, 60 degrees, square root of below would be the square root of 3. Square root of above would be the square root of 1. So square root of 3 divided by the square root of 1, which simplifies to be the square root of 3 over 1, or just the square root of 3. Okay, again, you will get lots and lots of practice with this. Okay, important things to remember. Again, this is some of the stuff that I see very frequently as far as mistakes and errors. Be sure to attach the sign that identifies the angle in standard position. Okay. If it's negative, make sure you have a negative. All right. Step 2 there. If there is a square root in the denominator of the fraction, be sure that you rationalize the fraction. You will run into this in a couple situations. If you are taking the tangent of an angle, then it is possible that the square root in the denominator is not simplifiable, Okay, and you will have to rationalize, so multiplying the top and the bottom by that square root. The other situation is when we come up to day 4 and day 5, I actually switch from doing the regular and original trig functions to doing the reciprocal functions. So you will have to find the reciprocal of the original. So you will find them as if they were sine, cosine, tangent, and then you would take that answer and flip it so that it's cosecant, secant, and cotangent. Okay? Step 3 there is very highly important. Again, do not give me a decimal answer here. I am looking for the exact value. Okay? If it is 1/2 and you give me 0.5, that would be okay. However, if it's the square root of 2 divided by 2, then you cannot give me that as a decimal. Okay? I want the square root of 2 over 2. Okay, lots of examples here. 6 of them to work through. Number 1, again, I'm going to take whatever the angle is that I give here, and I'm going to find the reference angle. So I'm going to again plot that as if I'm plotting it in standard form, and I'll work through it. So here I would add 360. And if I add 360, that gives me negative 450. I'm going to bring that over here. I can add another 360, and that's going to give me negative 90 degrees. Okay, so if I plot that, I have my initial side, and then my leftovers is negative 90, so it's straight down. Okay, I have 1, 2 rotations, and then the extra. So I start here, I go down and around, that's 1, 2, and then finish. Okay, here I have that unique situation of a reference angle being from here to the axis itself again. So this is a reference angle of 90 degrees. Okay. You would then take your thumb and put it down. Okay. And then remember, with sine and cosine, there's always an over 2 here in your palm. Okay, so if I take the square root of the fingers below, because sine was the square root of below, I have the square root of 1, 2, 3, 4. So square root of 4 divided by 2, which I can simplify. The square root of 4 is 2. So I have 2 divided by 2, which is 1. Okay. The next thing you have to do here is then again make sure you understand if it's positive or negative. I'm taking sine, which refers to my y values, and the terminal side here drops down. Okay, and the y values down here are all negative. So my answer here is negative 1. Number 2, again, I have a negative value in there. It's a negative 390. I'm going to add 360 to that as well. Okay, which gives me negative 30 degrees. Again, I'm going to plot that as if I'm plotting this standard position. My initial side, my 30 degrees is here. I have 1 full rotation, so I start here, I go down and around, and I have 1. Okay. Again, my reference angle is the angle closest from the terminal side to the x-axis. Here that goes back to the positive x-axis, so it's right here. So my reference angle here is 30 degrees. Okay. 30 degrees then again aligned with your ring finger. So I'm going to shade in this one. Again, I have that over 2 aspect here. And then I'm going to work it out. So if I take the square root, now that I'm working with cosine, the square root of the fingers above that line. Okay, I'm going to put this down. I have the square root of 1, 2, 3. So I have the square root of 3 over 2. Okay, you'll notice that the square root of 3 is not a perfect square, so I'm not going to mess with that. That's my answer. I then need to check my sign. Okay, all students take calculus. So all students take calculus. Okay, all functions are positive here. Only sine would be positive here. Only tangent is positive here. Only cosine is positive here. We are taking the cosine of this value. So because it's cosine and it's in quadrant 4, then this is my answer. It is positive, square root of 3 over 2. Okay, number 3, I'm going to take and I'm going to go ahead and graph the negative 240 because it is already between 0 and 359. Okay, so I have the positive x-axis is my initial side. Again, it's negative, so it's negative 90 down here, negative 180, negative 270, so I'm actually 30 degrees back that way. Okay, I have just the partial rotation, so I start here and I go down and around. And again, now I'm going to find that reference angle. That reference angle, again, being the closest distance from the angle itself to the x-axis. So here, the closest one is actually to the negative x-axis. So my reference angle is what? From 240 back to 180 is 60 degrees. Now if I take 240 minus 180, I get 60 degrees. So that means 0, 30, 45, 60 degrees. Okay, again, I am focused on tangent here, which was the square root of the fingers below divided by the square root of the fingers above. I don't have that over 2 in the middle here. Okay, so if I put down that 60-degree finger, square root of below is 1, 2, 3. So square root of 3 divided by the square root of above. Again, leaving my 60-degree finger down, the square root of 1. Okay, and then again, I can simplify here. I can't have a square root in the denominator. However, I can simplify first. The square root of 1 is 1. So this is the square root of 3 over 1, or just the square root of 3. Okay, now the question is it positive or is it negative? Again, focusing on the aspect here. All students take calculus. My terminal side is in quadrant 2. The only one that is positive is S, or sine. I am taking the tangent. So because it's the tangent and not the sine, then this is negative. Okay. Number 4, now we have some positives here. Number 4, I'm going to start. Again, it's between 0 and 359 already, so I'm going to go ahead and just graph it. Initial side, 30 degrees is about a third of the way up. Okay. If I go here, I go straight up and then done. My reference angle is between here, again being the shortest distance. And from 0 to 30 is 30 degrees. So now I have this finger. I have the over 2 in my palm because again now I'm back to doing sine. Okay. Lay my finger down. That represents 30 degrees. Again 0, 30, 45, 60, 90. So I lay down that 30 degree. Sine was the square root of the fingers below. So I just count the numbers below. So I have the square root of 1 over 2. Again, simplify. So the square root of 1 is 1. So that gives me 1/2. And then again, the question is it positive or is it negative? Again, all students take calculus. If this is in quadrant 1 like it is, then all values, no matter if I take sine, cosine, or tangent, all of them are positive. So the answer here is positive 1/2. Number 5 is a large enough number now. I have to subtract again and do some rotations. I subtract 360. When I do that, that gives me 420 degrees. I'm going to subtract 360 again. That gives me 60 degrees. Okay, so now I can graph that. This is my initial side. 60 degrees positive up here. Okay, right there. I have 1, 2 full rotations. I start here, go around, up, and around. 1, 2, and done. Then again, my reference angle is between the closest x-axis and the terminal side. The closest x-axis here, which means that this reference angle is from 0 to 60, or 60 degrees. Again, that coordinates with my pointer finger. Cosine again, so I have the over 2 in my palm. Okay. Lay down your 60-degree finger. Again, cosine is now the square root of the fingers above the finger that's down. So this is the square root of, again, 1, right? There's only 1. Divided by 2. Again, simplify. Square root of 1 is 1. So this is 1 over 2. And then the question is it positive or is it negative? The terminal side falls in quadrant 1. And again, referring back to the all students take calculus, all stands for all. Doesn't matter if I'm taking sine, cosine, or tangent. If the terminal side is in quadrant 1, the answer is positive. And the last one here, number 6, tangent of 135 degrees is already between 0 and 359 degrees. So I can go ahead and graph that. So I have the initial side, 135, this is 90 degrees, this is 180, because again it's positive, so I have to rotate counterclockwise. 135 is directly in the middle. Okay, and I go straight to it. I don't have any rotations, so I go right here and done. Okay. My reference angle again is the shortest distance between the terminal side and the x-axis. If you notice here, this is closer again from here to the negative x-axis. So this is my reference angle here, not the one going here. Okay. So how do I go from 180 back to 140, 135? I just take 180 minus that 135. Which gives me 45 degrees. That's my reference angle. Okay, so that's my middle finger here. Okay. If I take the tangent of 45, again, I'll use my right hand now that I'm on this side. Tangent of 45 is the square root of the fingers above, the square root of the fingers below, divided by the square root of the fingers above. Okay, so I have 2 below, so it's the square root of 2, divided by the square root of above. So again, square root of 2 equals, reduce, anything divided by itself is 1. Okay, so the value here is 1. Is it positive then, or is it negative? Again, referring back to the all students take calculus. This terminal side is in quadrant 2. That's that upper left-hand quadrant. It says S, or students, and only sine is positive. I'm taking tangent, so this would be a negative 1. Okay. Something tricky that happens with these, especially with tangent, is you can have the option of an undefined thing. Okay, so if you have 0 in the denominator, make sure you remember that I cannot divide anything by 0. It becomes undefined. It does not become 0. Okay. However, 0 in the numerator would end up being 0. Okay. As always, if there's any questions, comments, or concerns, please feel free to reach out to me. You can post on this link, or you can email me or send me a message on Remind.